Patterns in Sequences. A lesson for Math 10. In this lesson, we will work with patterns. Recognizing and extending patterns are important skills needed for learning concepts related to sequences. Okay, let's have this activity. Observe the number of blocks needed to build each figure. So let's have, for the first figure, we have how many blocks? There's only 1. For the second figure, we have how many blocks? Let's have 3. For the third figure, let's try to count. How many blocks do we have? We have 1, 2, 3, 4, 5, and 6. So for the third figure, we have 6 blocks. How about for the fourth figure? How many blocks do we have? Let's count. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So how many blocks do we have for the fourth figure? We have 10. Again, for the first block, we have 1. For the first figure again, we have 1 block. For the second figure, we have 3 blocks. For the third figure, we have 6 blocks. And for the fourth figure, we have 10 blocks. So the numbers we have are 1, 3, 6, and 10. So what pattern have you observed to get the number of blocks for each figure? So again, we have 1. What number to be added to 1 to get 3, which is the number of blocks for the second figure? So that is simply 1 plus 2, and that is 3. Now, what number to be added to 3 to get 6, which is the number of blocks for the third figure? So that is simply 3 plus 3. So we come up with 6. Now, what number to be added to 6 to get 10 for the fourth figure? So that is 6 plus 4. We come up with 10. Okay. How about if we will get the number of blocks for the fifth figure? What number to be added to 10 to get the number of blocks for the fifth figure? Let's try to find out. How many blocks will be needed to build the fifth figure? So that is 1. If you still remember, for the first figure, we have 1 block. Second figure, we have 3 blocks because we added 2. For the third figure, we added 3 blocks to get 6. So we have 6 blocks for the third figure. For the fourth figure, we add 4. So 1, 2, 3, 4. So we come up with 10 blocks for the fourth figure. Now the question is the number of blocks needed to build the fifth figure. So we have 1, 2, 3, 4, 5. So we added 5 blocks to come up with the total number of blocks needed to build for the fifth figure. So for this figure, how many blocks are there in all? So we have 15 blocks. So this is our fifth figure. So let's try to count. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So we have 15 blocks for the fifth figure. How about if we will be asked more? This one. How many blocks will be needed to build the sixth figure? So if you still remember, for the fifth figure, we added 5 from the fourth figure to get 15 blocks for the fifth figure. Now, for the sixth figure, how many blocks do you think will be added to 15 to get the total number of blocks for the sixth figure? Since it's sixth figure, we will add 1, 2, 3, 4, 5, 6. We will add 6. Now, to complete the number of blocks for the sixth figure, if you still remember, for the fifth figure, we add 5. For the fourth figure, we add 4. For the third figure, we add 3. For the second figure, we add 2. And this is our first figure. So if we are going to count the total number of blocks for this figure, we have 21 blocks. So this is our sixth figure. So let's count the number of blocks. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. Okay. So we have a total of 21 blocks. Okay, now let's observe the data we obtained. Using this table, we have figure number. We have 1, 2, 3, 4, 5, 6. So we have up to sixth figure. For the number of blocks, we have 1 block for the first figure, 3 blocks for the second figure, 6 blocks for the third figure, 10 blocks for the fourth figure, 15 blocks for the fifth figure, and 21 blocks for the sixth figure. So try to remember the number of blocks for each corresponding figure. So we have again 1, 3, 6, 10, 15, and 21. Okay, let's go over on how we get this number of blocks for each figure again. So we have again the table with the figure number 1 up to 6 and the number of blocks for from 1 up to 21. Now for the first figure, that's 1. And for the second figure, it becomes 3. What did we do to 1 to get 3? We simply add 2. For the third figure, it becomes 6. So what did we do to 3 to get 6? We simply add 3. That's 3 plus 3, and that's 6. Now what do you think will be the number added to 6 to get 10? That is 4. So 6 plus 4, that's 10. Now, what are we going to add to 10 to get 15? That is 5. So 10 plus 5, and that is 15. So what do you think is the next number to be added to 15 to get 21? And that is 6. So 15 plus 6, that's 21. So if you observe, we simply add counting numbers to get the next desired number of blocks for each figure. Okay, so how about if we are asked to find the number of blocks needed to build the seventh figure and the eighth figure? So for the sixth figure, we have 21 blocks. What are we going to add to 21 to get the number of blocks for the seventh figure? That is, since that is seventh figure, so we will add 7. So 21 plus 7, and that is 28. Okay, very good. So for the seventh figure, we have 28 number of blocks. How about for the eighth figure? What are we going to add to 28 to get the number of blocks needed for the eighth figure? Take note, it's 8 figure. So we will simply add 8 to 28 to get, let's try to find out. And that is, okay, 36. Very good. So that's simply 28 plus 8, and that is 36. So therefore, for the seventh figure, we need 28 blocks. And to build for the eighth figure, we need 36 blocks. You got it? Okay, again, we will go over to our table. Figure number 1 up to 6 and the number of blocks for each figure. So it's 1, 3, 6, 10, 15, and 21. As what we have shown on the previous slide, to obtain the number of blocks in the nth figure, we simply need to add the consecutive counting numbers from 1 to n. So as what we have shown a while ago, we simply add 1 plus 2 to get 3, then 3 plus 3 to get 6, 6 plus 4 to get 10, 10 plus 5 to get 15, 15 plus 6 to get 21, and so on. So we simply add consecutive counting numbers. Now, if we will look for the number of blocks for the nth figure, so we will simply add consecutive numbers from 1 to n. Okay? Next is, how about if we will look for a certain rule or pattern to get the formula in getting the number of blocks needed for a certain figure? Shall we say 50th figure or 30th figure? Do we need to add all the counting numbers up to the desired number of blocks needed for that figure? So to make it easier, we need to find a certain formula to make it easy and quick for us to find the number of blocks needed for a certain figure. So if we are going to look for this pattern, we have 1 plus 2 plus 3 plus 4 plus 5 plus 6. These are actually the numbers we add to get 21 blocks for the sixth figure. For the sixth figure, we have 21 blocks, if you still remember. So we add 1, 2, 3, 4, 5, 6. We come up with 21 blocks. How did we get the 21? Let's try to look for a certain pattern. Now, if we will try to pair numbers from the innermost to the outermost, so we will try to pair first and last number. That's 1 plus 6, that is 7. If we will pair 2 and 5, add them, we come up with 7 still. If we will add 3 and 4, it's again 7. So how many 7 do we have here? So there are 3 pairs of 7. Or we can also say 7 times 3, and that is 21. So this is the same as adding the first and the last number, which is 1 plus 6 is equal to 7, times half the last number. What's the last number? That's 6. Half of it is 3. So that is 3 times 6 plus 1 is equal to 21. Is it correct? 6 plus 1, that is 7. Times 3, that's 21. So other way of writing 7 times 3. So that is, this is actually the sum, adding the last and the first number times half of the last number. So we come up with 21. So we will let n be the last number. Thus, the general rule for this pattern is n over 2, quantity n plus 1. So this n again will represent as the last number. And then this 2, we got this from the statement here that we will have the last number, which is 6. So that's why we have 2 here. And then n again, this is the last number. If you noticed 6 from here, this is our last number. So n, this is our last number, plus 1, which is the first number. Look at here, this one. So the general rule for this pattern is n over 2, quantity n plus 1. So that general rule or pattern for this example is very important to get for the desired number of blocks needed for a certain figure. So from that, we can say that in solving for the number of blocks needed to build the nth figure, use the general or the nth term, and that is n divided by 2, or n over 2, quantity n plus 1. Okay, how about if we will ask, how many blocks needed to build the 20th figure? Are we going to add all the consecutive numbers up to 20 to get the 20th figure? So no need for us to get for the number of blocks needed for the 20th figure in an easier way. So we will simply apply the general rule or the nth term or the formula we just derived. So our figure is the 20th figure. Therefore, our last term here, last number is 20. So we will replace n with 20 So it's 20 divided by 2, that is 10. Then 20 plus 1 equals 21. So 21 times 10 is 210. So how many blocks needed to build the 20th figure? That is 210 blocks. So see, we don't even add all the consecutive numbers from 1 to 20 to get 210. We simply apply the general term that we just derived. That's n over 2, quantity n plus 1. Again, how did we get 210 blocks? Again, how did we get 210 blocks? That is 20 over 2, that's 10, times 20 plus 1, that's 21. So 21 times 10 is 210 blocks. So as easy as that. Okay, so this one. The numbers 1, 3, 6, 10, 15, 21, 28 we obtained in our activity form a sequence. So what is a sequence then? A sequence is a function whose domain is the set of positive integers. It also means an ordered list of numbers. Each number in a sequence is called term. Take note, each number in the sequence is called term. And those numbers we just talked about a while ago form a sequence. In the sequence 1, 3, 6, 10, 15, we can denote the term as 1, that is our first term, or A sub 1. This will be read as first term, which is equal to 1. Next is 3. So that is our second term, or A sub 2. This is our second term is 3. And 6, that is our third term. 10 is our fourth term, so that is A sub 4. And 15, that's our fifth term, so that is A sub 5 is equal to 15. So this is how to denote our terms in a sequence. We have A sub 1 equals first term, this is our second term, third, fourth, and the fifth term. Okay, how about if the general rule or nth term of the sequence above is denoted by, the nth term is denoted by A sub n, or this will be read as nth term, is equal to n over 2 times quantity n plus 1. So this is our formula or the general rule that we are going to use to find the desired term for this particular sequence. Again, this will be read as n term is equal to n over 2 times quantity n plus 1. Okay, let's check if the general term we obtained will yield the sequence 1, 3, 6, 10, and 15. Now, if we are going to find out if that general term we've just flashed a while ago is really correct, that could coincide with the terms here for our sequence, we will simply substitute the consecutive positive integers n. So, our first term, that's A sub 1. First term is equal to, our n here is 1. So, we'll replace our n here with 1, and this one is our n previously. So this is 1 half times quantity n, or 1 plus 1. So this is 1 plus 1, 2 times 1 half, which is equal to 1. So take note, this is our first term, 1. And we get the correct number, which is also 1 for our first term. For the second term, that is 3. Applying the formula or the nth term, we arrive. That is second term is equal to, this time our n will be replaced with 2 since it's second term. So our n here again will be substituted by 2 because again this is our second term. So 2 plus 1, that's 3. Yeah, 3 times 2 over 2, this is equal to 1. So 3 times 1 is equal to 3. So this is our second term. For the third term, that's 6. Okay, so we have third term. So our n here is 3, so we replaced n here with 3, and the other n here is with 3. So we have 3 plus 1, that is 4, times 3 halves, that is simply 4 times 3 is 12. Divided by 2, and that is 6. Next, we have the fourth term, which is 10. So how did we get 10? That's our fourth term. So our n will be replaced with 4. We also have n here with 4, and the other n here is 4. So we have 4 divided by 2, that is 2. 4 plus 1, that is 5. So 5 times 2 is equal to 10. Okay, so we come up with the fourth term, which is 10. Fifth term is 15. Now, let's try to find out if 15 is correct. So, fifth term, that's a sub 5. Our n here is 5. Another n here will be replaced with 5, and another n here will be replaced with 5. So, we have 5 plus 1, that is 6. And then 6 times 5, that's 30. Divided by 2, and that is 15. So, applying the general rule we just derived a while ago, we come up with the correct terms of our sequence, which is 1, 3, 6, 10, and 15. So, our general term is correct. Yes, it does. It really coincides with the numbers or the terms in our sequence. Okay, so next we have this one. Try this. For each sequence, look for a pattern, then make a guess of its general term. So try to look for a certain pattern so that we can guess the general term or the nth term of our sequences. For number 1, we have 1, 8, 27, 64. What do you think is the next term, next of 64 and another term here? Try to look for a certain pattern for this sequence. We have 1, 8, 27, 64. So we have the general term or the general rule of our sequence is n term is equal to n cubed. Why is it n cubed? Let's try to go over to our sequence. Our first term is 1. If we will raise this to the power of 3, that's 1 cubed, or 1 to the power of 3, that's 1. Next, this is our first term. Second term is 8. The second term, replace this with 2. 2 cubed, or 2 to the power of 3. That's 2 times 2 times 2, and that is 8. For the third term, so our n now is 3, okay, third, because it's third term, so our n is 3. So 3 raised to the power of 3, that's 3 times 3 times 3, that's 27. For our fourth term, that is 64. Fourth term, therefore our n is 4. 4 to the power of 3, that's 4 times 4 times 4, and that is 64. This is our fifth term, so our n here is 5. So 5 to the power of 3, and that is 125. Okay. Next, we have the sixth term. So that is 6 to the power of 3. That's 216. So the complete sequence is 1, 8, 27, 64, 125, and 216. We simply raise each consecutive counting number to the power of 3 to get for the terms of this particular sequence. Okay, how about this one? 1, 1/2, 1/3, 1/4. What do you think is the next two terms? If you notice, the numerators here are all 1, right? And the denominators are, what do you think is the denominator of 1 here? It's simply 1, followed by 2, followed by 3, followed by 4. So what have you observed on its denominator? So that is simply counting numbers, right? So therefore, the general rule or the general term for this sequence is n term is equal to 1 over n. It's because we have our n. First term, we have 1. So 1 over 1, that's 1. Second term, so replace this with 2. Replace this with 2, and this will become 1/2. Third term, replace this with 3. Replace this with 3. So third term will become 1/3. For the fourth term, so replace this with 4 and replace this with 4. So we have 1/4. So what do you think is our fifth term? That is simply 1/5. And this will be 1/6. So our complete sequence then is 1, 1/2. Next denominator, that's 3, since this is our third term. For the fourth term, denominator will be 4 because it's fourth term. For the fifth term, the denominator will be 5 since it's the fifth term. And here, for the sixth term, the denominator is 6 since it is the sixth term. So this is now the complete sequence of this particular example. Again, the general term is simply n term is equal to 1 over n. And this n represent the counting numbers, consecutive counting numbers. So this is the general term for this particular sequence. So that's it. Thank you and hope you learned something from this video presentation.